Okay, we're live. I believe everyone should be able to see my screen. Let me go ahead and go to slideshow mode. Okay, let's dive in. We've got a few more people trickling in, which is totally fine. Welcome to the third ever, I think, Tuva Project Community Meetup. Today's topic, we're going to dive into claims data modeling for BI. And Tom is going to drive the bus on this conversation. Like with every meetup, we keep it pretty informal, right? So feel free to ask questions throughout. The purpose is to learn more about healthcare data and how to do analytics, right? So that's the purpose, and so we can just kind of keep it informal. I've got a few things that I'll run through kind of at the beginning, and then we can get into the fun stuff. So here's our agenda. I'll do kind of a quick community update, and then a couple roadmap announcements, and then we'll get into Tom will take it over, and we'll get into the fun stuff. So just in terms of the community update, last year was like a really big year for the community. We ended the year, we at the beginning of the year, there were 3 organizations using Tuva in production, and we ended the year with 32 organizations using Tuva in production. And there's another 20 organizations that are in the process of implementing it right now. What this metric is, there's lots of different ways to measure kind of adoption, this graph on the left. What we really mean by that sort of adoption is like basically somebody's using Tuva as their analytics data model for all claims and clinical data. So like if somebody's just kind of like, testing it out or just using terminology or something like that, that's great, but that doesn't count into this metric. So this metric is really kind of like signifies like pretty deep adoption, because it's a lot of work to map your data to the data model. So that growth has been really exciting. The other thing that's grown a lot is the Slack community. It's tough to like kind of measure this. Like, there's people in Slack that probably joined once and they were like, oh, what am I doing here? Like I got lost and made a wrong turn and found myself here, and they never come back. But then there's also people that I'll talk to that I have never seen them post in like Builders Ask or anything, but they'll be like, oh, I follow the conversation every day when I talk to them. So that's like equally surprising. So one of our goals, we're building all this, we're trying to like open source all these like healthcare analytics, healthcare data transformation tools, but we're also trying to create a community where we can have conversations in the open about what is the best way to transform healthcare data to do analytics and those types of things. And so that's why we track both these metrics, and so we'll continue to track these and hopefully find even better ways of tracking that growth over time. In terms of we've really found like our sweet spot to be kind of in value-based care analytics, like ACOs, ACO type, pop health type analytics is where we found our sweet spot, as opposed to life sciences, real world evidence type research, or as opposed to more like health, like hospital use cases, like rev cycle or supply chain or stuff like that. And so our plan is really to double down on that. And so a lot of the open source things that we are building are going to be with that target audience in mind this year. And so just better, more emphasis on like medical economics and things around like quality and risk and things that matter to value-based care. We are, one thing that's exciting about kind of that focus on value-based care and ACOs is we're going to be doing a collaboration with the University of Pennsylvania and the Gates Foundation. Some folks at UPenn actually got a grant to build open source analytics for Medicare ACOs. Basically, the thinking is like, hey, there's all this like complicated stuff that you have to do in order to transform claims data into meaningful data for reporting and analytics around your ACO. And gee, wouldn't it be great if that was open source? Is the idea. And so if you know Zeke Emanuel, he's like a big health policy person. I believe he was like fairly instrumental in the Obama White House. Him and one of his collaborators, Daniel Schenfeld, who I've gotten to know fairly well over the last couple of years. We basically have talked over the last couple of weeks, and we're going to collaborate on building this, and then basically it'll be kind of using Tuva as the data model, data transformation layer to go from like raw Medicare CCLF data and BCDA data to usable data, and then building some open source dashboards that run automatically on top of that produce meaningful types of analytics. And so it'll kind of be a continuation of some of the work. If you've seen the dashboards, if you've seen some of the dashboards that are on docs today on the tuvaproject.com, we've built some of these Power BI dashboards, and we've open sourced these. But you have to have a Power BI license to use these. And so not exactly sure what modality we'll build the dashboards in for that collaboration, but the thinking is it'll be completely free, completely open for any, kind of Medicare ACO or anyone to use. So we're pretty excited about that. And then I guess the last thing I'd just mention in terms of the community is like, we're going to like really increase the focus on events this year. Like this is kind of our third ever kind of community meetup. And so, and we just think this type of like discussion and conversation is just like really useful for folks that are in the healthcare analytics industry to be having more often. And so we kind of have like three flavors of sort of events that we're really interested in, and we think other folks might be as well. One is what we're calling the research collaborative, which is basically like as we like open source kind of like analytics or data, or kind of research analyses that run out of the box on top of Tuva. For example, what's the impact of GLP-1s on major acute coronary events, or like what are we actually seeing in the data from these things? As we develop those types of analyses and data stories and we put them out there, let's schedule a research collaborative meeting where we bring the results that we're seeing from that analysis, and other folks that have because they have their data in Tuva, they can just copy that code and run the analysis, and then we can like basically see if are the results generalizable? Like, is it look like the evidence is more or less consistent? Whatever we're practice-based evidence. Is that your word for what I'm saying, Ben?
Yep. I've had that work really well at venture talks before, is flipping it and making it practice-based evidence. Yeah.
Oh yeah, I like that. Is it okay if I steal that from you?
All yours, dude. Go for it.
So that's kind of the thinking around the research collaborative practice-based evidence. Then Tuva Talks is basically we're thinking it'd be fun to have, there's so many of us that have had kind of like, we've been in this industry for a super long time, and we have like, it's just interesting to hear from other people about, hey, here was my path through the industry. Here's how I got started. Here's what I learned along the way. Here's where I'm at right now. Here's what I'm doing right now. And personally, I just find those sort of like personal stories pretty interesting. So trying to start doing those on a more regular basis, or start doing them and then do them on a regular basis of just having people on to talk about their kind of healthcare analytics journey. And then the last is to just do more targeted office hours, just in terms of like a big focus for us this year is like, I guess to go back to the adoption, we think these numbers are like pretty interesting because we actually don't think Tuva is like super easy to use right now. Like the documentation isn't maybe as great as it could be. It's confusing how to get started. There's, people are running into errors and things. So it's great to see this documentation, even with how, or this adoption, even with, kind of things not being where we hope they would be on like in terms of ease of use standpoint. And we think one of the things we can do to help with that is just more like kind of hands-on education around like, hey, like if you're trying to do something, you got a problem, like let's talk about it. So as we start doing these things, we'll post in Slack about them and on LinkedIn too. For people that may not yet be in the Slack community, and it's as always just open to anyone who's interested to join. Couple quick roadmap updates, and then it's over to Tom to present for the main dish. We're rolling out 3 paid products this year, and these are not things that are new products in the market. Like you can go get these products from other companies. We are building them because we think these things should kind of integrate better and easier with analytics. And frankly, they're really expensive also. And we think they don't have to be as expensive as they are. So in April, we are launching Enterprise Master Patient Index and NCQA HEDIS measures. These are things that, we're designing these things to integrate really closely with the open source, with the data model. And so that it's kind of, as folks on our team, as we on our team have built these things, built integrations with other vendors that do these things in the past. That's kind of the pain that we're trying to eliminate with these products. And risk-adjusted benchmarking is going to come out in July. And basically what that is for a bunch of different cost, utilization, and outcome metrics that you can calculate in the Tuva data model, we're training machine learning models on a large kind of third-party claims, all-payer claims data set. And then those machine learning models produce patient-level expected values kind of at different grains, like at the member month grain or at the encounter grain. It depends on the metric, but then that allows you to do kind of like observed versus expected sort of benchmark, risk adjusted benchmarking. So we'll share more about those as they come out. This is a screenshot of the Master Patient Index application. It's actually a software application that has a matching algorithm behind it and just integrates really nicely with the Tuva data model in terms of where it gets the raw patient data out of and how it integrates the matching back into it. And we'll have an actual live demo of this that we can walk through and show interested folks in the next couple of weeks. And then for the NCQA HEDIS measures, you might have seen a few months, or I don't know how, maybe it was 2 months ago or something, where NCQA had us take down the open source measures that we were building. So unfortunately, we had to remove like 10 measures that were NCQA copyrighted measures that we had coded as SQL into the open source. That was a bummer. But in parallel with all that, we had been working on a partnership to offer certified versions of all 80 NCQA HEDIS measures to organizations that wanted certified versions. Look, taking down the stuff from the open source was a little bit of a bummer because we weren't even saying they were certified. We were just kind of like, hey, here's a breast cancer screening measure. We followed this spec. Anyway, so this is going to come out in April, where if you have if you've adopted the open source, or if you're paying, regardless, you could be a pure open source customer, or you could have a relationship with Tuva where you're paying us to help you transform your data with the open source as a managed service or through our cloud offering, and we can turn this on kind of with the flip of a switch. So at least, so it's a paid add-on, but at least it makes it easier to get access to these measures, and you can calculate care gaps and things like that if you need. That is it for my rambling. And so I think with that, Tom, I'll turn it over to you.
Awesome. Thanks, Aaron. I will talk for just a minute on this slide, and then I'll take over screen sharing if that's all right. Before I jump right into this, I guess just to give a little bit of background, I won't make this a full Tuva talk like Aaron was talking about, but I've been doing business intelligence, data visualization type analytics for almost 15 years now, about 10 years specifically within healthcare, and maybe the last 6 or so in pop health, value-based care analytics. And so when we were talking about ideas for discussion for community meetups, one of the things that I thought would be really helpful to talk about is some of the different nuances and things you have to account for when you're designing a data model for the business intelligence layer. It's a little bit of a different data model than your typical like statistical analysis, or maybe an Excel-based table-based analysis. And so my background, like I said, is in data analytics. I'm not a DBA, not data engineering. I'm not an expert at Visual Studio or anything like that. And so a lot of what I've learned has been through trial and error on the job. Like, how do I make my dashboard do this? I know it can do this. I just don't know how to structure the data to do it. And so what we want to do today is walk through some of those common pitfalls with data and moving to that visualization layer, and how to think about it to be able to design the data model the right way to get the interactivity that you want, as well as correct calculations for your end users. I heard something from the Knowledge Project in Shane Parrish, if anyone else follows that. I know Aaron does, but a long time ago, they were talking about how complexity within a project is almost a constant. And what happens is you basically shift where that complexity is. And so the simpler, easy to use dashboard that I want to make for a very low code, low technical user, so it's really simple and easy for them to click around, probably means that you're shifting a bunch of complexity to the back end. And as a developer, you have to figure out how to account for all these different simple interactions in an actually fairly complex way. And so what I'd like to do is walk through 3 different examples, kind of building on each other to go through what the differences are between doing like an Excel or statistical style analysis with healthcare data to a fully interactive, simplified dashboard that an end user with fairly basic technical skills can use and really drill into the data to answer their own questions in real time. So what I'm going to do is I'm a visual person, and I also really love examples that hit the problems I'm trying to solve. There are only so many kind of sales, Joffle shop, dummy data set examples I can use to translate some of my questions. And so when we're using healthcare data to address some of these things that, especially in pop health analytics, right, everyone is doing these types of calculations. And how do we do that the right way and get that knowledge out there for the community so that everyone's not trying to reinvent the wheel? So all that to say, I'm going to do something risky and do a live demonstration of a lot of this to talk through these different problems and how I found that I could solve them and what's worked well in my experience from building these types of dashboards. So I'm going to be using Power BI for this demonstration. It's pretty similar to if you were to use pivot tables or pivot charts in Excel, to Tableau. Some of the other BI tools, they can all do a lot of the same things. So some of the specifics might be a little bit different, but the concepts will still apply to those other tools and other types of visualization layers. So can everyone see my screen? Do I need to zoom in at all? Is the table okay? Okay, cool.
Looks good.
So just to orient you to what we're looking at here, This is the CMS synthetic data data set. And so we've got a bunch of claims data over a couple years for Medicare style made up people and made up claims. So there's no PHI here, but it gives us a nice data set to work with to do this type of demonstration because it has all that typical healthcare pop health analytics type of data that you want to work with to be able to answer some of the questions and for this learn how to structure the data. So what I've done here is I've just created a simple table that brings in a couple different fields that you might have if you were to do a person level analytics problem. So if you were to do, this is the simple method, right? So if you were to do like a simple linear regression or something like that, right? You'd have this type of a data set where you have one row per person, and then you have a bunch of information related to that person. So the person is the unit of analysis, if you're familiar with that terminology. We've got some demographics here, and then we've got some indicators or flags or features, whatever you want to call them, to indicate whether that person has some of these chronic conditions. So we've got hypertension, obesity, MS, RA, and then paid amounts here. So we could do a regression and say like, okay, well, what does age, sex, race, state have to do with these different chronic conditions? What do they have to do with paid amounts? And we can get all our coefficients and get a model doing that. We can also create some graphs off of a data set like this. So we could do something really simple, like we could plot age against paid amount and put our person ID here. So we get something like this, where we get one dot per person with their age on the x-axis and paid amount on the y-axis. So, you know, you would expect as people get older, maybe their paid amounts go up as they become more riskier, etc. But then to be able to interact with this more, it's really about dragging and dropping columns, right? So if you want to give this to an end user so they can explore it, well, if they want to look at hypertension, they'd have to drag that column over to something like, you know, color, or in this case, legend. And you can start to slice and dice the data to see what are the paid amounts look like for people that had hypertension versus those that don't. But then if you're interested in a different disease, you have to actually go to the data model and kind of, it's a clunky drag and drop approach, right? And so if we're designing a dashboard for a non-technical end user, right, that's something a report builder could do. But what I'd really like to do is somehow have like a condition filter that allows the person to just flip through all of these conditions in a really simple, user-friendly way, right? I don't want my end users to have to drag and drop columns, because then you have to make sure everything's named in a way that they can find what they're looking for, and they have to know how to use the Power BI or Tableau, right? I want it to be all self-contained and simple. And so the way you would do that with a data set like this is you have to pivot it. What you need is what I would say is this is a wide data set, right? You've got one row per person, and then you've got a bunch of columns that it's kind of extra information about those people. In order to do that simple slicer type interaction that I'm talking about, what you need is you need to refactor your data set. So if we want condition to be the interactive element, we need a table that's long, that's one row per person per condition. And so we still have our demographic variables here, but now instead of having a flag for each condition, we just have one row that says what the condition is, and the paid amounts with that. So what happens is we now have as many rows in this data set per person as conditions that they have. So for example, if someone had obesity and hypertension, they would have 2 rows in this data set. They'd have one row with hypertension and one row with obesity. In fact, we see that right here. And so that's really important to keep in mind, so that as you're doing your visualizations, you're not duplicating your paid amounts or other metrics that you're aggregating, that you slice and dice it the right way so you get the actual values, okay? So when you've got a data set like this, what you can do is, if we rebuild our scatter plot here, and make sure I'm using the long version of this, we've got our age, paid amount, we've got our dots for our people there. And then what we can do is put condition on the legend. Oops. And then we want to add a slicer with our condition filter. And so now this takes that complexity of having to drag and drop different fields like I was talking about. We've accounted for it in our data model. And so now the end user can simply select one of the conditions that they're interested in, and both table and scatter plot will filter accordingly to only show the members with those conditions. So now we've gone from a wide data set to a long data set in order to enable this type of interactivity for our end users of the specific dashboard. Okay, so this is a simple kind of more of a thought exercise of what the differences in the data model looks like and what we're trying to accomplish. And what I want to do is move into something that's a little bit more complex, using how do we calculate a per member per month metric, something that's a little more, we need a numerator and a denominator. It's a little more complex than just having like a simple patient level table like this. Before I move on to that, I just want to pause quickly and see if there are any questions about what I presented here with this simple example.
A question about if the simple example is really that simple. This doesn't give us the ability to filter by not multiple sclerosis and not hypertension. I imagine you could essentially just do the opposite of the condition and add that to your pivot as well. Is that how you'd suggest tackling something like that?
Yeah, that'd be one way to do it. The other thing you might want to do is, you know, you'll see, right, if I don't have anything selected, that, and let's take condition off of there, right? Like we start to get some weird numbers, right? Like, because it's adding the ages together for all those different rows, right? But if you select one, then they start to look right because you're only looking at that single row. And so you're right, this doesn't allow you to multi-select. It also doesn't allow you to have nothing selected. And so one way to address that would be to add those rows to your table so that they come up as additional selections. That might or might not be a viable option depending on, right, like if this was the full list of chronic conditions, you wouldn't want to have to create a row that has every possible permutation of different combinations of chronic conditions, right? And so I might address that through a slightly different data model. But if it was like this and you just wanted to add an all condition, all you'd need is another set of rows in this table with, you know, no conditions selected, and have it just be one row with all the members and their paid amount. And then you would force the user to select something, and then they could select that one or one of the other conditions.
One other method might be to have a count of my records per condition, and that way I could calculate into my paid amount how many records are being returned for each person, and then get to the individual summation of that person's paid amount by dividing by, if I have 4 records, therefore duplicating the paid amount by 4. Include a count that I can put into my calculation in my aggregation to make sure that my dollars match up correctly.
Great. Any other questions? Otherwise, we'll move on to the moderate example.
Tom, just to maybe like, if I was going to summarize the principle that you're getting through these examples, is like understanding the grain of the table that supports the visualization you're trying to build, and how filtering impacts the grain that's kind of the key principle.
Yeah, definitely. And when you are in the design stage of building a dashboard, it's really important to try to flesh out all of the different interactive elements that you want and what you want users to be able to slice and dice by, because all of these use a row-based filtering approach, right? Anything that you want to be interactive will impact what grain the table's at or how you build your data model. And so the more of those interactive elements that you can anticipate and build around from the beginning, the better your data model is going to be to actually accomplish what you want for the end user. All right, cool. Thanks for the questions. Let's move on to our moderate complexity problem with calculating PMPMs. So what I've got here is a table that's just looking at my claim line item information. So this is one row per claim line. We've got some basic claim information columns here: claim start dates, end dates, the person that was associated with the claim, the paid amount. You know, you could also pull diagnosis or procedure, DRGs, any of that information on here. But I wanted to show this just to get a sense of what the underlying table looked like and what grain it was at. And for reporting, right, you might aggregate this to a year-month level, for example. So I put this table together beforehand. I just did a year-month based on claim start date. So we're looking at a couple years of data, summing the paid amounts for that data, and then we've got our count of people here. And so if we want to do a PMPM calculation based off of this, you know, you can do your create a new measure or column depending on what your particular visualization layer calls it. And we'll do a PMPM calculation where we want to sum the paid amount and divide that by the number of people, right? So actually, let's patient. Why am I not getting? Go this way. Oh. All right. So that'll do our math that we want here, and we can throw that on there. And that gives us our paid amount number, or our PMPM numbers. But it's not actually that simple. This is a way to calculate PMPM, but this isn't the number that we actually want. And the reason for that, the interpretation here, right, is we're only counting the number of people that actually had claims during that time period. And so our denominator is not correct. We're not getting the whole pool of people. And how do we deal with that in our data model to be able to calculate the numerator and the denominator correctly, along with how we want to filter and slice and dice it? And what we need to do in this case is we actually need to have a dual fact, a multi-fact data model, a galaxy schema, whatever you want to call it. So Power BI and other data visualization tools will really emphasize having a star schema, having one fact table and a bunch of dimensions off of it. This is a case where calculating PMPMs is essential to pop health and value-based care analytics. And so a lot of people are trying to figure out how to do this. And the way you do it is through having a second fact table. So there's some other things in here. We don't need to look at any of that. For now, what I want you to see is that this data model actually has two fact tables here. So we've got our fact table that has our paid amounts and our other claims-based values that we either want to sum or slice and dice by. And then it also has a fact member month table where we can actually calculate the true denominator of our member months for that time period. So this table has one row per member per month of eligibility. And they're joined together on that membership, that wide membership table that I started out with. And so what that allows us to do is if we filter something at the person level, it will either include or exclude them from both the numerator and the denominator. It'll exclude their eligibility as well as their claims, or include both, right? So we have alignment between our numerator and denominator. So this is just a one-to-many join from our member table to the two fact tables. This actually is just the model view within Power BI, Ben. It's not an ERD. Yeah, I mean it is, but it's not a tool outside of Power BI. Yep. So just to show you what those tables look like, because again, I think examples, and I'm a visual person, so that this type of thing really helps. So here we've got our fact member months. And so this is our denominator, right? This is how many member months we had. So for January 2016, there were actually 942 eligible enrolled members in this plan. Only 313 of them actually had claims in that month, right? And so this is very much inflated from what it should actually be when we use the correct denominator, right? So let's do, for consistency's sake, let's get this here. And that is our paid amounts from fact claims. Actually, let me do this. That's our numerator. This is our denominator. And then let me do one more here. And what we need to do is a new measure. And I'm going to call this contributive PMPM. And so what this needs to be is sum of paid amount from claims divided by the sum of member months from our member months table. Oh, I already built it. But that's what it would be. Let me put it here. Oh. All right, so this, see, there's a huge difference between these numbers. So this number, this PMPM, is taking our paid amounts from our numerator fact and dividing it by the true member months from our member months fact, right? And we can see that this, like I mentioned, right, these numbers are inflated, and these are the actual numbers based on the enrollment for the corresponding month and the paid amounts there. So now, how would we filter this? How would we add some interactivity to this to be able to filter it and allow our end users to drill in the way they would want to? Well, what we can do is add a slicer or another visual, or you know, whatever your tool, visualization tool, calls them. And we could add something like encounters, right? So let's do just a real simple encounter group filter. And let's say we want to look at just our inpatient claims. What do those PMPMs look like? This is an even more extreme example of these differences between these two ways that PMPM can be calculated, right? So let's walk through this. If we look at just inpatient claims, we're filtering our numerator to only those claims that were tagged as an inpatient encounter, and we're getting the paid amounts for all of those. And in this view, what we're seeing is actually only 8 people had inpatient claims in January of 2016, which gives us a PMPM, maybe a relative PMPM, I would call it, of $13,390. Okay, which if you're familiar with inpatient PMPMs, that would be insane, astronomical, just really expensive, right? And again, the reason for that is because we're not including the full true denominator of what our enrollment was for that month. So what this allows us to do is filter our numerator based on different dimensions of the claim, but preserve the true denominator within our fact member months to actually get what I would call the contributive PMPM, which is $112 per member per month for inpatient claims in January of 2016. Does that make sense? I want to, oh,
Can
go
I
ahead.
ask a quick question? I'm new to claims data, and I just want to make sure I understand like the key, maybe the key takeaway here. It
Yeah.
seems like what we want to do is we have a member months table that is like a one-to-many join to the claims. But instead of doing that join upstream, we're like, we want to filter on the like many claims thing, and so we're doing the join later inside of here instead. Is that or not even a join, but like you aggregate both independently and then do it here? Is that a like fair way to understand what's happening and like why we would do it this way?
Yeah, so it kind of depends on what your final table is, or your tool is, and how you actually do that. Like if you were to do this with SQL queries, it'll look different than Power BI. But effectively what you're doing is you want to be able to calculate your denominator, how many member months you have, independently of what you're filtering the claims for.
Yep.
So yeah, and so in this case, in that data model, right, I'm just joining them to the members. So there's not actually a join between fact member months and fact claim summary. So what this allows me to do is, if I want to, in this case, right, if I wanted to filter something on the member level, like if I wanted to do an age filter and just look at everyone, 60 to 70, and then those 70 plus or something like that, right? That would filter the member table, and then because this is joined to both member months and the claims, it'll filter those groups out or include them based on that join, right? And then your calculation would just calculate each table independently.
Yep.
Does that help?
I think a little bit, but that
Okay.
it's pushing me down the correct path to like figure out the rest myself. Maybe is a better way to say it.
Tom, in your example, you're literally filtering on the encounter group or the type of encounter. So that is filtering the rows in the claim table. But because this data model is set up with 3 different tables, that filtering does not impact the filtering of the member months table. So you still end up with the right denominator count. That's what's happening, right?
Yeah, exactly. The encounter that I added there is from the claims table. And so it's just filtering this. It's not doing anything to either of those two.
Right. I guess maybe that's a good way to frame what I was thinking about. If you never wanted to filter anything at all, you could just join it ahead of time and you wouldn't have a denominator problem, I think.
Yeah, you could do aggregations in the data model if you wanted to. You could calculate your PMPMs beforehand. I've typically taken the approach of not doing aggregations as long as I can. So in the very last layer, because that's what allows you to be able to do that slicing and dicing, right? If you've aggregated it in the data model, then there's only so much the end user can do without starting to have incorrect calculations, because you don't have those base numbers to slice and dice. You pre-aggregated it, right?
That makes sense. Yeah, that's the key takeaway for me. Yep.
Okay, cool. Yeah, great question.
For when you're filtering, for example, for acute inpatient, you're changing the numerator, right? But you're not changing the denominator because you still use the same number of member months. But when you filter by age and you want to say, what is my total PMPM for people with more than 70 years? Are you filtering the denominator there too? And you only look at eligibility for people in that age group?
That's correct.
So you're okay. In that situation, you would change the denominator.
Yeah. And that probably would have been a great complex example. I went a different route and wanted to say, what if we wanted to look at conditions? So I'll do a demonstration of that, Coco, but just think, this could apply to age or any other like person level characteristic. So the Tuva data model has a chronic condition data mart, and we've got a couple of different cuts of the data within that data mart. There's CMS chronic conditions, which use the CCW chronic conditions warehouse definitions. There's a long and a wide version of those tables. There's also a Tuva chronic conditions data model that has a long and a wide version of those tables. The definitions of the underlying conditions are just slightly different. Tuva includes a lot more than the CCW does. And in this case, when we do trainings on Tuva, we like to highlight those and say, look, depending on your analytical use case, you might prefer the wide table versus the long table. And so they're both available. So it makes it easy for the end user, the end analyst, to be able to pull what they need. In this case, if you think back to the simple example, right, we want a long table because we want to be able to have a condition column that has all the different conditions that we want our end user to be able to slice and dice by. And so what I can do here is add another slicer and get our conditions from the data. I've already brought it into the data model. And what this does is the conditions are at the person level. And so this condition table is joined to that member table, which then will filter the other two fact tables. So if I scroll up a little bit here, this is a bridge table, which is a little bit outside the scope of this. We can talk about it if we need to, but our DIN conditions, so one patient can have many conditions, one condition can have many patients. So we're filtering at the patient level, and then that is going to filter our two fact tables for both the numerator and the denominator, right? So you could think about this as like using it for age, you could use it for dates, right? Anything that you'd want to do that would need to filter both sides of that PMPM calculation. So if we apply one of these condition filters, in this case, actually everything changes, right? And so I want to walk through those two different PMPM calculations, and let me put this one back on here so that we can see what those differences are and help interpret what's actually happening here, and what you might need for your particular dashboard use case. So what we're doing is by selecting cataracts, we are limiting our entire data set, both the numerator and the denominator, to only members that had a cataract, okay? And so you can see our member months drop significantly. So we've got a couple dozen, maybe, members with cataracts in any given month. And then the claims on the numerator side, these are any claims for those members. So it's not necessarily claims or services, right, that were for cataracts. It's just any services that that member had, and that member had cataracts, right? So our PMPM then will be our $7,000 divided by the 21 member months to give us a PMPM of $356. The difference of if you just had that claims table without the member months is you'd still have that $7,000, but only 12 of those members with cataracts had claims during that month. And so that's going to give you a PMPM of $600 because you've cut your denominator in half, essentially, because only 12 people had claims in that month, whether it was for cataracts or not, right? Does that make sense, Coco? Does that help? Like if you do like your age groupings or something like that, right? You'd slice and dice, you'd filter both the numerator and denominator.
Yeah, but what do you think of it like when you're looking at acute inpatient PMPM, you're not changing the denominator, but when you're looking at a specific condition PMPM, you are changing your denominator. Why do you think it makes sense to do it differently for those two cases?
Yeah, it depends on what your question is and what you're ultimately trying to answer with the data. The way I think about it is if you want to look at just what your inpatient PMPMs are, it doesn't really matter whether someone had an inpatient encounter or not, right? You still want the whole bucket of people you're at risk for. If you think about like value-based care contracts, right? Like if you're an ACO, you're on the hook for the entire pool of members. And so you've got your paid amounts for just the inpatient claims, but your denominator is that whole pool of people. But if you want to have targeted interventions or do more analysis around specific conditions, or maybe you are specifically like, targeting certain chronic conditions and you want to see what your PMPMs are for those chronic conditions, you don't necessarily want to include all of the members for those because you're just looking at that subset where you'd want to see just people with that particular condition.
I think there's almost like 3 different ways to do it. I mean, you can get just so complicated here. Like if you just think about conditions and you've got the claims table, the member table, and the member month table, right? You could actually tag claims with conditions, you could tag members with conditions, or you could tag member months with conditions. And those are like answering very different questions. If you tag the claims and then you filter on the claims, now you're just looking at the claim cost where the claim was associated with one of those conditions, like the primary DX or some diagnosis of code on the claim was specifically for the condition of interest. If you tag the member, you're saying, okay, this person had type 2 diabetes. I want to look at all the spend for people that had type 2 diabetes forever, right? No start and end dates. Like, it's just like, if you ever had type 2 diabetes, I'm looking at all your claims history for all time. The member month way is the third way then, where you're like, well, maybe like we want to go from like a when you were diagnosed forward kind of, right? And so then if you're tagging member months with conditions and you're filtering there, you're kind of limiting your denominator to like when the time period over which we think somebody actually had the condition. So it's like 3 very different ways of doing it, 3 very different answers. And you got to know what the question is that you're trying to answer to model the data the right way to get there.
Right, and one of those ways is the PMPMs are mutually exclusive versus not in the other way. And so, so you're double counting all the conditions if you do it with the second method where you're tagging patients with conditions.
Right.
Let's see. I'm looking at the time. Maybe to quickly kind of sum up and conclude here, what I was hoping to do is put together a demonstration that kind of builds on some data modeling principles of how to think about how to build your data model to support the types of calculations and interactions that you want in your end product, your end goal. And so this was a simple way to walk through something with a healthcare data set. And effectively, those are the principles that I use to build this cost drivers dashboard, which I think I showed at one point in our community meetup previously. This is available on GitHub in our analytics gallery. And what I showed today is really what I use to build this. And what this type of dashboard allows you to do is to get total PMPMs, average monthly enrollment for a selected date range, and then calculate PMPMs, PKPYs for all of these different encounter types. There's a lot of detail here that you can quickly understand where the money's going, how many encounters you've got, your cost per, and then you can slice and dice it by different member level conditions. And so, to be able to design this, you have to have the end goal in mind, ask the questions of what you want your interactive elements to be, how you need to calculate the metrics for the versions of them that you want, because there's more than one way to do it in some cases, like we talked about. And then from there, you can go to the data model and figure out how you need to transform it to be able to support this type of interaction and hopefully simple, user-friendly way for the end user, so they don't have to be a technical Excel or SQL person to be able to drill into and do essentially exploratory data analysis with that particular universe that you've built for them. We've got just a couple minutes. If there's any other questions, be happy to try to answer more if there's stuff from the community there.
I have a philosophy question for you of where this data modeling should occur. My first time seeing Power BI behind the scenes. The tool is obviously built for data modeling, as opposed to doing the data modeling in the database layer and maybe even having like flattened tables that pre-calculate this, so your BI tool is just a visual element. Where's the right place to do this work?
So even though it's not Philosophy Friday, I'll allow your question. It's a great question. I love that. I think that what I was hoping to not get distracted by is there are tools within Power BI to do everything I was talking about, so you don't have to do any of this in the SQL layer, right? And it's kind of frustrating. That's one of the ways that it makes it difficult to learn this by yourself, because you're like, I don't know where to do this. What I've learned, and the way I try to approach this is kind of the way I responded to Brandon's question actually, is I would do as much of it in the underlying data layer as you can and as you have access to. I think part of the reason Power BI has some different kind of workarounds to do this stuff, like you can do like you can do a calculated field with a case statement, and you can make a slicer like this that says, I'm going to call this inpatient, and when it's inpatient, then swap this column in there. Otherwise, swap that column in there, right? And so there's workarounds to achieve that, but I think those are designed for situations where the report builder doesn't have access in the database to be able to make changes there. And so without that, they'd be stuck, or they'd be waiting on a DBA team to build the table that they need to actually be able to do their work in the visualization layer. So it kind of depends on what your access level is. But if you have access to the data layer, at the database layer, I would do as much as you can there, because that preserves more of your ability to build a data model that can slice and dice the way you need it to for your end user, without sort of doing pre-aggregations that you wouldn't have to do otherwise in order to have that kind of interactivity. Yeah, great question, Ben. Any other questions? We might have time for one more.
Cool. Let's leave it there then. Thanks a bunch,
Sounds
Tom.
good.
This is great.
Yeah. Thank you, everyone.
All right. We'll see you guys.